Hi students, in this video I'll be going through the JYSS 4E 2020 Prelim Mathematics Paper 1 question 90. So this is a question regarding the stem and leaf diagram as well as mean and standard deviation. Okay, so let's read the question. Okay, students from group A took a mathematics test. So the results are shown in the stem and leaf diagram. Okay, so a stem and leaf diagram is actually very easy to read. Okay, so there are numbers on the stem and there are numbers on the leaf. Okay, so how to read the diagram? Okay, they always give you a key below. So 4/2 means represents a score of 42. So over here we have 4/3. So it means that one of the students got 43 marks for the test. Okay, 4, 3, and one got 4, 4. Okay, 44 marks. Okay, so another one got 52, 56, 58, and so on. Right, so in part A, we are asked to calculate the mean marks. Okay, so to calculate the mean marks, what we need to do is to add up the scores of all the students. So over here, if you count, there's total number of 15 students. So add up all the 15 scores and divide by 15, then you will get the mean, right? Okay, you can actually use your calculator to store the values. Right, so if you have forgotten how to store the values in your calculator, I'll be putting a link in my description of this video. So you can click on the link and it will lead you to another YouTube video, okay, done by another person. Okay, that will show you how to store the values in your calculator. Right, so you don't have to go and manually add up each of the individual scores and then divide by 15. All right, all you need to do is input the data inside your calculator and then you will be able to recall the values for the mean. And later on, when you need to recall the value for the standard deviation in part C, it's also going to be much easier. All right. Okay, so if you store the values inside a calculator and you calculate out the mean, you should be able to arrive at an answer of 64.2. Okay, so on average, this class of students, they scored 64.2 marks. All right. Right, so the next part they ask us to explain why the mean that you calculated in part A, right? It may not be an appropriate average to use to summarize the marks obtained by the students. So the key word here is why the mean may not be appropriate, okay, to summarize the marks obtained by the students. Okay, so to answer this question properly, you need to observe the data set. Okay, but before we look at the data set, answer the question, I would like to show some info from some websites to understand more about the mean, right? All right, so over here you can see that this is the Ministry of Manpower website of Singapore. Okay, so there's actually this page which I found that shows you what is the mean used for. Right, so for example, in this page over here, okay, they give an example of finding the mean trading hours of a group of employees. Okay, so why do they want to find the mean trading hours of a group of employees is that they can compare an individual's, annual training hours, okay, to judge if he or she has a comparable opportunity for training. Okay, so let's say they calculate the mean training hours of everyone to be 10 hours per year, okay, per employee. And then there's this one particular employee who only underwent 2 hours of training. So it means that this employee actually was undertrained because on average, okay, all his peers and colleagues had to attend 10 hours of training or got to attend 10 hours of training, but he only got to attend 2 hours. Then maybe something can be done for this particular person, right? Okay, so the mean can also be used to compare the training hours for different groups of people. So for example, if they want to find out if the female employees in the company, right, have a ample opportunity for training, they can calculate the mean for females and then compare to the mean for all employees, and then to see if the females have a similar number of training hours or not, or maybe they had less opportunities for training. All right. Okay, so other users for the mean would be, if let's say they want to increase the wage of all the employees, the salary of all the workers in the company, right, by 5%. So instead of taking everybody's individual salary and then increasing by 5%, to find out, and then after adding up all the increase, right, to find out in total how much it will cost the company. All they need to do is to calculate the mean of all the salary and then increase the mean by 5% and then multiply by the number of employees, and they will know how much it will cost the company to give each worker a 5% wage increase. Okay, so these are some examples of uses of mean, right? Okay, so the next one is that we want to discuss how does the outlier value affect the mean. So what is the outlier value? Okay, an outlier value is one that is very far apart from the rest of the values in the data set, right? So for example, let's say for your particular exam, your WA, all your subjects got A1, right? Then one of your particular subject got F9. Then if you were to calculate the mean for all your grades, right? Then the F9 is going to pull the grade up, the overall mean up, right? Okay, so we may end up with a mean like 3. Okay, but actually, except for that one subject which you didn't do well, the rest of subjects you got A1. So now the mean becomes a poor representation of your overall performance, right? Okay, so that is how outlier can significantly affect the data set, all right? Okay, so let's take a look at this also. Okay, so the mean, as you can see from here, is meant to give you an idea of where the center is located. So if there's an outlier and the outlier pulls the mean upwards or pulls the mean downwards, then it will cause the representation of the center to be shifted. Okay, can shift it to somewhere, okay, or can shift it so far away that it becomes a poor representation for the entire data set already. Okay. Okay, so let's go back to the question. So I hope that this particular short sharing has been useful for you. Okay, so let's go back to this question. Okay, so they asked us to explain, right, why the mean calculated in part A may not be an appropriate average to use. Okay, so in fact, if you were to, okay, as you can see over here, there is indeed an outlier value of 98, right? Correct? So in fact, if I were to calculate the mean again without the 98, okay, so without the 98, without 98, okay, if I calculated the mean, okay, if you go and try to calculate, you actually get 61.8. Okay, so with the 98 is 64.2, without the 98 is 61.8. Okay, so 64.2 will be somewhere around here, right? Okay, 64.2. Okay, so you can see when the mean is 64.2, when we try to use this 64.2 to represent the center value of the data set, right? How many students are below the mean? 1, 2, 3, 4, 5, 6, 7, 8. 8 students are below the mean. 8 out of 15 students. So it seems like half the class okay, was performed below average. Okay, or slightly more than half the class performed below average. Okay, but if we were to disregard the 98, okay, then the mean becomes 61.8. Okay, 61.8 will be somewhere around here. Okay, so now only 6 students, 1, 2, 3, 4, 5, 6, perform below the mean. All right, so this gives a better representation because as you can see, most of the people are around this region. Okay, it's only that one particular guy, okay, who performed exceptionally well, okay, in that particular test. Okay, so he may have some special preparation or what, okay, such that he was able to do much better than the rest in the test. Okay, but he doesn't represent including him in the data value to calculate the mean will cause the representation of the center value to be less representative of the data set. All right. Okay, so let's craft our answer and see how we can answer the question. All right. Okay, so the extreme. Okay, so what we'll say is that we always acknowledge this outlier or extreme value of 98. All right. So I will say something like this: the extreme. Okay, so you can say the extreme or slash outlier. Okay. Score of 98 will. Okay, so I like to use the word inflate. Okay, but inflate also stands for pull up. Okay, so to pull up Okay, so if it pulls down, then you just say lowers lah. Okay, lowers or pulls down. Okay, or pull up will inflate the mean and make it a poor representation. So remember, we are trying to use the mean as a single number to represent the center point of the data. Okay, but if it's being put up by the 98, then it becomes a poor representation, all right? Point of the data set. Okay, so the extreme outlier score, okay, inflates the mean, okay, and make it a poor representation of the center point of the data set. Right, so I hope through this you'll have a better understanding of what the mean actually represents and how mean is being used, okay, in a data set. All right. Okay, so find the standard deviation of the marks. So same thing, standard deviation, if you have stored the values earlier, okay, then you will be able to recall it from your calculator. So in your calculator, the symbol for standard deviation is this, okay? Okay, this symbol, okay? All right, so if you calculate the standard deviation, you should be able to get a 13.1. Okay, as you can see, the standard deviation is also quite big. Okay, so now I'll bring you to another website to understand more about the standard deviation. Then we'll come back and discuss more about this, okay? Why the standard deviation is so big. Okay, so we'll go back to the website. Okay, so standard deviation. Okay, so this is Wikipedia. So in statistics, the standard deviation is the measure, okay, of the amount of variation of a random variable expected about its mean. Okay, so basically, the higher the standard deviation, it means that there's more variation in the data set. So a low standard deviation indicates that values tend to be very close to the mean. Okay, while high standard deviation indicates that the values are spread out over a wider range. Okay, so high standard deviation means the data values are more spread out, okay, which means lower consistency. Okay, whereas a low standard deviation means the data values are less spread out, and it also means a higher consistency. All right. Okay, so the symbol just now that I drew, okay, the symbol is actually known as sigma. Okay, so it's sigma x. All right, so standard deviation. Okay, so let's go back to the question. Okay, so remember, high standard deviation means more spread out, lower consistency. Low standard deviation, less spread out, higher consistency. All right. Okay, so you can see over here, the standard deviation of 13.1 is actually quite big. Okay, in fact, in part D, they say that students from group B, the test mark standard deviation was only 6.8. So why was this so big? Okay, so this is expected because of this 98, right? Okay, this 98 actually caused the standard deviation to become very big. Okay, because it's very far away from the mean, right? So that's why the standard deviation is so big, okay, because of that 98 value. Okay, so let's answer part B. Okay, students from group B took the same test. Standard deviation was only 6.8. So use this information to comment on the two distribution. So group B's standard deviation of the scores is way lower. Okay, so this means that the scores of the students have a lower spread about the mean. So this can also mean that in group B, the students have a greater consistency in their test score, right? So this is basically what we're going to write. So based on the lower standard deviation, okay, in the test score for group B, the students in group B have a greater consistency in their test scores. Okay, so based on the lower standard deviation, okay, it will lead to greater or higher consistency in their test scores. Right, so I hope that through this video you have been able to better understand about mean and the uses of mean and how outlier will affect the mean. Okay, and as well as you have better understanding about standard deviation and how it affects the spread of a data set. Right.